For more than a century, wormholes have lived at the edge of physics, mathematical oddities permitted by the equations of general relativity, yet thought too unstable to ever exist in the real universe. They are shortcuts through space-time, bridges that connect distant regions of the cosmos, tunnels where a journey of thousands of light years collapses into a single step. To us, wormholes feel like the ultimate fantasy, a passport to distant galaxies, a loophole in the cosmic rules, a doorway through the fabric of existence itself. But what if the greatest paradox is not that wormholes might exist, but that we may already be living inside one? Across the universe, we observe galaxies behaving strangely, stars bending light in impossible ways, and structures larger than anything our models predict. We see cosmic filaments stretching across unimaginable distances, connected by voids and arteries of matter. We see the universe expanding faster than it should. Some physicists have begun to ask a question once dismissed as absurd. What if our universe isn't simply expanding? What if it is flowing, drawn through a vast geometric structure we can't directly perceive? What if the cosmos itself is shaped like a wormhole? This is the wormhole paradox. The idea that the universe we inhabit might not be a simple, flat, continuous space. That instead, it might be a curved, folded, multidimensional tunnel, a structure that influences everything from the motion of galaxies to the birth of stars to the mystery of dark matter. And if that's true, then the universe hasn't just been evolving. It has been traveling. Einstein showed us that space is not an empty stage where matter performs. It is the performance itself. Space bends, stretches, folds, and warps. It responds to mass and energy like water rippling around a passing boat. But the equations of general relativity allow for something even stranger. A geometry so warped that 2 points in space-time become connected by a tunnel. This tunnel, a wormhole, is not made of matter. It is made of geometry. Normally, a wormhole would collapse instantly. Its walls would pinch shut faster than light could travel through. But under certain conditions, the presence of exotic matter, extreme cosmic inflation, or the topology of higher dimensions, a wormhole could remain stable. And if it remained stable, it could shape the universe around it. Some cosmologists now propose that the large-scale filamentary structure of the universe resembles the interior of a wormhole. Not metaphorically, literally. Galaxies may not merely form clusters. They may adhere to the curved geometry of a cosmic tunnel, stretching along its length like lights along a bridge. The voids between these filaments may not be random emptiness. They may be regions where the wormhole curvature dips, warps, or spirals. And if this geometry exists, then our universe may be far more dynamic and far stranger than the expanding balloon we learned about in school. Dark matter is one of the great mysteries of modern physics. It outweighs normal matter 5 to 1. It shapes galaxies. It sculpts clusters. It forms halos that hold entire cosmic neighborhoods together. But despite decades of searching, we've never detected a single dark matter particle. Not one. What if the reason we can't find dark matter is because it isn't matter at all? Some physicists argue that the effects we attribute to dark matter could be the gravitational consequences of a wormhole structure embedded within space-time. The curvature of a wormhole could mimic the pull of invisible mass. Light traveling through these warped regions would appear to bend around an unseen force. Galaxies rotating too fast for their visible mass might actually be responding to the geometry of a cosmic tunnel. In this model, dark matter becomes a kind of illusion, not a substance, but a shadow cast by the shape of space itself. If we live inside a wormhole, What we call dark matter might simply be the curvature that holds the tunnel open. We've been trying to detect particles that don't exist because we've misunderstood the structure we inhabit. Wormholes do more than connect distant points within a universe. They can connect entire universes to each other. In the early moments of the Big Bang, quantum fluctuations may have created countless bubble universes, each with its own laws of physics. Some of these bubbles may have collided. Others may have remained forever separate. But a few may have become linked by wormholes, tubes of geometry stretching between realities. If our universe is one such bubble, then what we call the Big Bang might not have been a singular explosion. It may have been a bridge opening, a connection forming, a tunnel stabilizing between dimensions. Our universe could be a pocket of space-time shaped by forces originating elsewhere, forces that flowed into this cosmos through a wormhole at the moment of creation. This idea reshapes everything we know about cosmic origin. We may never observe other universes directly, but we may be able to detect the gravitational fingerprint of a wormhole opening, a subtle, persistent pattern embedded in the cosmic microwave background, or a distortion in large-scale structure that cannot be explained by inflation alone. In other words, the doorway through which our universe was born might still be visible. And if so, we are not just part of the universe. We are part of its geometry. The wormhole paradox becomes even stranger when we consider higher dimensions. The universe we perceive has 3 dimensions of space and 1 of time. But mathematically, space-time works just as well, and sometimes better, if more dimensions exist. In certain models, the universe is a 4-dimensional membrane floating in a 5-dimensional bulk. Gravity can leak between dimensions, creating effects that mimic mysterious forces. Wormholes may exist naturally in the higher dimensional realm, appearing in our universe only as projections. Imagine a 2-dimensional creature living on a sheet of paper. If someone lifts the paper and folds it, the creature sees impossible distortions. It thinks its world is bending, but in reality, the bending happened in a higher dimension. We may be those creatures, living in a 3-dimensional surface that warps in ways we cannot perceive directly. If the universe is embedded within a higher dimensional wormhole, then the very notion of distance changes. Galaxies that appear billions of light years apart might be neighbors in a dimension we can't sense. The universe may be far more connected, far more compact, and far more intricate than our limited perspective allows. The wormhole paradox forces us to confront a possibility more profound than the existence of wormholes themselves. Not that they might exist, not that they might form pathways between galaxies, but that the universe, our home, our cosmos, our reality, may already be one. We may be living inside a cosmic shortcut, a tunnel carved through space-time, a structure shaped by physics older than our stars, older than our galaxies, older than the universe we know. And if this is true, then everything we see, from the rotation of galaxies to the expansion of space, may be the signature of a geometry grander than we ever imagined. We are travelers in a universe that may itself be traveling, passengers in a cosmos shaped like a bridge, witnesses to a reality that bends, folds, and connects in ways we are only beginning to understand. The wormhole paradox is not a puzzle to solve. It is an invitation to look deeper, think stranger, and imagine beyond the boundaries of the universe we believe we inhabit.